Alright, looks like we're live. Sweet. Alright, let's take a look at this. Background on convertible arbitrage. Okay, this is going to be very dry for a lot of you people, but let's see if I can actually understand what the hell he's talking about here. Arbitrage, simultaneous purchase of sale of two things at different prices, small profit on, okay, correct. About the Rothschild brothers, spread out, buy and sell currencies at far-flung rates. Okay, that's correct. Convertible securities are candidates for arbitrage because one asset is exchangeable for another. The convertible bond in exchange for a stock. Imperfections in this market can create opportunities by simultaneously buy one asset and sell the other. Small frequent profits with little risk. Yep. Skillful identify opportunities. Literally wrote a book on blackjack. Beat the dealer. Blah blah blah. Using the strategy. Okay. Yeah, so this makes sense. Basic strategy is to reduce the casino's advantage. Process of card counting. Okay. In statistical terms, each hands are not independent. That's correct. If a player can keep track of cards that have been played, his knowledge of what remains can give him an advantage over the house. Yeah. Card count. If you card count in a fucking casino and they catch you, they ban you. Straight up. And you can never show back to that casino ever again. Casino throwing card counters. He went to convertible arbitrage. All right. Someone buys a security that can be exchanged for common shares, and then he sells short some of the same shares. Bond is convertible into 40 shares, and those shares are selling at $20. The value of the underlying bond should be $800, correct? Because you should be able to convert those 40 shares at $20 a share. The bond usually won't sell at $800, but rather at some higher price. Okay. Bond embodies an option that is worth $800 of stock. The combination is worth more than $800 because an option provides an additional way to pay for the asset's potential upside. Oh, no, it's not a haircut, man. It's a ponytail. Yeah, I don't know if you can see it, but it's actually a ponytail in the back. And I still need to dye my roots, actually. I have not done that yet. But basically, it's just talking about convertible arbitrage versus bonds versus stocks. He buys the bond and shorts the stock. Means he sells the stock. Stock goes up, then he expects the bond to go up as much. If he has more money invested in the bond than he does in the short position, the result can be reasonably attractive. If the stock goes down, he expects the bond to go down substantially less. Hopes for a mix of appreciating stocks and declining stocks. What? Okay. Use leverage to magnify this steady flow of modest profits. Okay, basically he's just looking for free money by buying the bond and selling the stock. Because usually the bond is going to be worth more because you have the option of converting it into stock. That's basically the underlying idea. How many shares is short in order to create the desired performance pattern? Generally, a properly priced convertible will capture a percentage of the underlying stock's gain and somewhat smaller percentage of the loss. This means that the percentage of stock's movement captured by the bond is variable, rendering imprecise the number of shares is short per $1,000 bond. And that number is usually less than the number of shares in which the bond is convertible. This is because the convertible bond are less volatile than underlying shares, and the arbitrator wants both sides of the position to be equally volatile. Thus, he won't short the full number of shares the bonds will convert into. Okay? So the question is, how much bonds do you want in conversion versus the amount of stocks you want to short? And I'm guessing that the equation he's going with here is that the more volatile the stock, the more bonds you would want. Just to level out the stability, which kind of makes sense, but it's also a little bit confusing at first, because you have to kind of know how these convertible bonds actually work. So there's no wrong answer in this hedging ratio. So as interest in hedge funds rose over the last 10 years, convertible arbitrage became the model of an absolute return strategy. It seems capable of grinding out returns in the teens almost every single year. This occurred without exposure to market fluctuations. Yes, because you are volatile neutral if you actually do this. Bottom table shows 1995 2003 the convertible arbitrage index. Annual returns, yeah, these are pretty good. The problem is that if you want to go, is that not everyone can do this since there's only so many mispriced bonds versus stocks that are available in the market. 12.8 per year for 9 years. Only 1 year down in 9, not just a loss of 4.4. It's a good record. Yeah, so the basis of this is that if a stock is more if stock A versus stock B is more volatile. Then stock B is going to be like if all the two companies are exactly the same, then stock A is going to be priced lower because of the volatility friction. But in theory, over the long period of time, that won't matter, and eventually the two bonds will converge to the same value. But the problem is that markets really hate volatile returns, so they'll put like a premium on that, and so they'll discount the stock by a little bit more. So let's say I have Apple, like one company Apple, and one other company like Apple Clone, and Apple Clone trades more volatile, right? It's gonna be priced at maybe 5-10% less than Apple itself. Now think of, instead of Apple versus Apple Clone is what's out there in the market, and Apple is a convertible bond. So in other words, because there's more volatility here, or maybe for whatever reason that Apple in the market is actually suffering some volatility, you can actually take advantage of that distortion and then eventually buy the bond and then sell the stock, or some version of that, in order to try and create this, create basically free money for yourself. The problem is that there's only so many of these free options that are available out in the market, because each time a asset is bought, it bids that asset up higher to eventually where there'll be an equilibrium between the convertible bond and stock. So not every single person or company can actually take advantage of this arbitrage. So that's basically what you're looking for when you're looking for a convertible arbitrage, or even any kind of trade in the market to begin with. Don't think of like trading options as like leverage. You should think of it as terms of a mispricing in the market, where the market is like assuming scenario A versus scenario B, that there are two different prices that come out of this, and that you can take advantage of that price differentiation. So anyway, I'll recommend, if you want to read this is from Oak Tree Capital by Howard Marks. I recommend you read this if you like his letters. I think they're much more easy to understand than any other capital management firm, even Berkshire Hathaway. And I think if you actually look through his past, 30, 40 years of memo writing, you actually learn quite a lot. In fact, that's exactly what I do. There's like 12,000 pages of reading, but each one I think it's a lot of knowledge that you can learn here. Whereas smart people have been able to churn out consistently good returns with small amounts of capital. Now it cries fighting over internal arbitrage ideas, armed with much more money. Yes. This is basically just talking about what I just said, with there being a limited number of arbitrage opportunities. In addition, I feel arbitrage and many other hedge fund activities are best thought of as piggybacking strategies, living off some underlying process that has a life of its own. Won't be that as long as thousands of investors are setting the price in convertible bonds and stocks. Blah, blah, blah. Outnumber the long only, then their buying power affects the price of convertibles, blah, blah, blah. Thus, depending probably on convertible arbitrage. Okay, so this is just more or less saying exactly the same thing, just in a historical context. This was a formula for steady profits. Money floods in. Yeah, if money floods in, then if there's a significant amount of capital and liquidity in the markets, these arbitrage opportunities don't exist, or are much harder to find. That's basically what I said. Fine. More money means lower returns. Correct. So you can only really do this in a bear. So I'm guessing he's saying that you can only do this in a bear market or low liquidity scenario. There's no such thing as a. There's no such thing. Yep. There's no such thing as guaranteed free money. Correct. Absolute death knell for profitability. If something can go wrong, something will go wrong. Yeah, so this is like examples of like black swans. S&P downgraded. This lowered the price of deal, giving the arbs a long position on their well. Yeah. And so basically, I think this paragraph here is actually kind of interesting. So everyone thinks that, as long as I'm delta hedged on my position, then I'll be fine. Except for the fact that when people usually get like margin called or something, then everything becomes correlated. So for instance, let's say I have Coke and Pepsi, right? And let's say Coke sells more. You should expect, and Coke stock price rises, right? You should expect that Pepsi stock will go down. Just because you should be like, if you're talking about like purely in the soft drink market, Coke goes up, Pepsi goes down, and vice versa. But then over time, the price movement of each of those will basically equal the trend of the soft drink market. Now, let's suppose like some freak accident happens, like Twin Towers go down, or like we have Lehman Brothers all over again, or in this case, long-term capital management. the firms that are exposed to both Coke and Pepsi will basically be forced to sell in order to cover their other positions. So in other words, even though I should be hedging my positions between Coke and Pepsi, if I have some really, really weird external event that happens and I need liquidity in order to cover my positions, I'm going to sell Coke and Pepsi in order to cover my other positions. This is where companies and trades that should normally not be correlated become correlated. So that's basically what this says here. So even though you're quote unquote delta neutral, there's always some tail risk that will blow you the fuck up. Piling in is dangerous. Okay. So if you try to follow the crowd without recognition of what you're doing, then you're basically really doomed to get fucked, because what it matters isn't just the asset that you buy, it's the price you pay for it. Virtuous cycle can turn vicious, blah, blah, blah. Yeah. I honestly think there's not much in this memo. I think if you're familiar with the way Howard Mark writes, and you read basically, I think, almost everything before 2005, this basically is nothing new. The only difference is that he's describing convertible arbitrage, in which case I think you're probably better off reading the Investopedia article on it. All right, this is the thread. How my dependence on Facebook cost me my startup $100 million and 110 jobs. Okay, so I know we're losing viewers, but basically we have 2 more minutes before my client shows up for the replay analysis. So just give me a sec, okay? Let me wait for him to show up. Okay, cool. Let's bring my client on. Since he seems to be ready, so. Yo, hello?
Yo. I can hear you.
Yeah, I can hear. Can you hear me?
Yeah, clearly.
Perfect. Great. Let me bring up your doc. How you doing, dude?
Hello? Hello?
Yo, hello. Can I hear you?
Yeah, perfect, yeah.
Great. No, I was asking like how you're doing, and how your practice has been.
Oh, okay. Man, it's been good. I'd say, I'm not doing that much of the exercise as I wanted to do.
Okay.
Because I'm being, kind of slow, trying all the steps you said to me.
Mm-hmm.
Try to always ask the questions and, be very methodical, not to patch and pray, as you mentioned. I always being aware of this, and it was slow than I imagined that it would be.
Yep.
But from the things you proposed to me to study, I finished the strings chapter, right?
Okay.
There are a few exercises I marked here on the book that I'm gonna redo.
Okay.
Because I found that it's good. I finished the modified binary search, right? And today, a few hours ago, I finished the binary search tree. All right.
Okay.
And today I did a mock with a friend just to see where I am.
Mm-hmm.
And he said that he never saw me like this,
Mm-hmm.
So maybe that's a good sign.
Mm-hmm.
And but it's still the bad points about the practice.
Mm-hmm.
Those little details, especially for the modified binary search.
Mm-hmm.
So there was some cases where I was not considering the +1, or this smaller things, they get me annoyed a little bit.
Okay.
And in my speed, I feel that putting all the words, all the steps that you said to me to take, it made me a little bit much more slow, being methodical that way. But I felt the progress. Yeah.
Yep.
Anyways,
okay.
That's it.
So a few things are the small things. Let me dive into what you just said before I go into other stuff. So you said small things, right? What are the small things that you feel like are tripping you up? And what do you think is like, getting you?
I'd say details. Like, for example, let me go to my practice diary. I think it's better with a practical exercise.
Okay.
Yeah, another thing that I just highlighted here. I think was just matter of pronunciation. I think I just need to train how to pronounce. Okay. Sometimes I just say the wrong way, but I was thinking in the right way. Like the time complexity, like the notations. I just need to pronounce them like the way it should be pronounced. Just another thing. Just took a note here. But anyways, let's go.
Okay.
Good point.
I know we haven't worked on time-space complexity just yet, but don't worry about it. We're going to get there later.
Great.
The reason why I want you to focus on one or two things at a time. We can always go back and go over those. But basically, I'm looking at this thing here, 45 minutes. Width is too long. Did you say it's too long to do the problem?
Which one?
Row 81.
Oh. Okay. I think it could be faster. It could be like in, say, in 35 minutes. Was like a medium problem, but I think I explained too much. He liked it, like the way I kind of evoluted, like kind of do the way you said to me to do. Yep. He never saw like that clarity while solving a problem. But I would say that it took like the maximum that it should take, and I should be faster. Like while explaining, be more effective with my words. I guess that's the thing,
Yep. I understand what your concern is. So like I said, in previous coaching sessions, is that the speed will come. And you'll know when you start, start removing the crutches when you already know what will happen. So what I mean by this, so let's say I did like let me give an example, like the serialized deserialized problem, right? Let's say I already understand. Let's say I'm doing the problem and I say, okay, I know I'm going to have a parenthesis here. I know I'm going to have a closed parenthesis here. I know that I'm going to put my comments in here. And so I don't need to write out the steps if I know very, very well and with like almost 99% certainty that if I skip this step, I can still go back and do that exercise if I need to, and it'll still be exactly the same. And you'll recognize when you can do that. It'll be clear as day. Like it'll hit you over the head like a 2x4. Like, oh, why am I doing all this mechanical stuff? I already know what's going to happen. It'll be absolutely clear to you, and then you could go faster. But until it like hits you over the head, I would not recommend going faster just yet.
Great. For example, for the last problem, right, the one that was like the last coaching section, I haven't took my notes yet because it was like I prefer to prepare the videos for you.
Yep.
But it took me like I'd say 48, no more, almost 50 minutes. But was like very clear what I need to do. Like there was no step where I didn't know what I was doing. And like the way you said to me to do, like go from the most naive, improve upon your efficiencies. Like I did if you go in the video, I think I did the video actually. But it took too long. I was being too repetitive and like doing this task over and over again and writing all this stuff, So yeah, I like just one thought that I had. Okay, if I know what is happening here, if I skip this part, I can go faster. But anyway, it's part of the process, as you mentioned. I feel
It's like when you're learning to walk, you have to start thinking like, oh, 1 foot in front of the other, 1 foot in front of the other, and then eventually you get to a point where it's like, oh yeah, now I can do this in my sleep. I know exactly what's going to happen.
I can run. Yeah.
Yeah. Okay. So right now we're just making sure that you can walk consistently without falling over. So don't worry about it. It's like, even though the Amazon guy is going to say you're slow, he didn't say you fucked up in solving the problem other than this like time-space complexity, which we haven't done. Everything else, if he's happy with it and how clean and methodic you are, That's a good sign. All that's left is really for you to make this natural and make it second nature. That's it. So just keep doing what you're doing, and eventually the speed will come. So don't worry about the time right now.
Good to hear this.
Good. Anyway,
okay.
I'm looking at all your other stuff. I could have only done one verification for the range. I built given the right order.
Yeah, there are like few steps that I should be more aware, like when analyzing my problem in the end, And I just taking note of this made me remember better. Like for example, one note that I took for I don't one of like BST exercises. I remember this thing. Okay, if I check one time, I don't need to check like here in the beginning, and I just improve upon this, which helped,
Okay. Result, but not in the right order as EPI solution. I should be aware of this, and that this was just like an order. Yep, you should be aware of this detail. I could have done this only one verification range. I want to see like what this is. It's kind of hard for me to like say. Well, I could have done only one verification for the range inside the traversal. The way I build was giving the right result, but not in the right order as the EPI solution. I should have been aware of this, and that this is just like in order to, So I want to see like what this exactly means. It's not clear to me.
Okay. Okay. Do you want me to show this?
Yeah, if you have like a Google Doc or something.
Hold up, I'm just gonna separate here for you.
Sure.
Because like the API asks me like the range, but I assume that this range can be given in any order, But the way that they created their answer was like just like an in-order traversal in the range, and I didn't consider this, If the interviewer said to me, okay, but like it should be in the order, I would be fucked up. Yeah.
Okay, so wait. Let me say.
Let me just
write a program that takes an input BST and an interval and return the binary search keys that lie in the interval. Okay, I see. So you're given a interval, and then you return all the binary search keys in that interval. So you're saying that you need to know whether or not you needed to return them in order or not.
Yeah, that is the question. That is the point. Yeah.
Okay. The thing is that to me, I'm already when I look at this problem and I don't even know what the answer is. I'm thinking, okay, well, in order binary search tree, I'm going to need to traverse the nodes, right? And because I'm forced to traverse the nodes in order to find the answers, most likely, I'm going to need to know if it's pre-order, post-order, or in-order traversal. And most likely, if I'm looking for a range, then I know that I'm most likely just going to look at, okay, I see I have a 16. So anything that is less than 16, I don't count. Anything more than 16, I'm going to count. And then anything less than 31, I'm going to count. And anything greater than that, I don't count. So if I do in order, I know I'm going to traverse from smallest to greatest, right? If I do pre-order in order traversal, if I do pre-order, then I'm looking at the children, which doesn't guarantee me what I look at. If I do post-order, the same thing. So I'd rather go in order or reverse order because that is just the most obvious move to me. That's it.
Oh, the thing of like just consider like things that are smaller than the range or greater than the range.
Correct.
I did it like as you mentioned. I messed up in the part of creating the result in the order that was asked.
Okay.
I'm gonna show you. I'm just separating like here.
Yeah. But you notice like the way I thought about it is like because I need to look at the BST. Therefore, I know I'm forced to traverse. Therefore, what traversal do I need to do?
Yeah.
I mean, the only way I break that logic is if I can solve this without traversing, which is not immediately obvious to me. So that's basically the way I think. And I think that, I'm very curious to see how you solve the problem without being in order. So, I'm very curious.
Just a minute. You'll see. I'm just copying here in our text file. Sorry about that.
Yeah, no problem.
Man, like overall, I can feel like the difference,
Yeah.
Like, I think it's a good thing. Yeah.
Okay, that's good.
Even the Dunning-Kruger effect, but anyways, I think it's a good start.
I mean, once you get past the peak of Mount Stupid or whatever it's called, and you hit the valley, that's when things start like, oh wow, I finally feel like I'm starting to improve, but I still suck.
Yeah. Makes sense.
Yeah.
Hold up, BST1. I'm gonna send you on Discord.
Sure.
Okay. Wow. The beginning of the mock interview, there are some Portuguese vocabulary, but the whole like mock interview was in English, so
Cool.
there's no.
Okay. Yeah, and then I'll look at the replay afterwards. I'm mostly just going through the diary, so.
Great. Okay, BST1. Here it is.
Cool.
I separated and attacked TXT file for you.
Great. All right, let me move this into a Google Doc so I can see this.
Mm-hmm.
Okay. Okay, the range lookup problem. Okay, so between 419, 6, 8, 12. Yep, brute force. Traverse all the nodes in the tree, store all of them, sort, and take the ones in traversal. Yep. Okay, so then what was the question that you asked yourself for the inefficiency? Let's see. Follow the BST property to visit nodes effectively, discarding the sides that are greater. Okay, yeah. So you're talking about pruning, not having to visit the nodes, correct?
Yeah.
Second approach. So then you have 6. Check whether or not. Oh, I see. Okay. Yep. Visit the node if the current value in the range is in the given range. Store the node if the current node. Oh, I see. I mean, it's not. This is not a total loss. I'm okay with this actually.
No, but this is the best solution. Like I guess.
Yeah. I mean, if we compare it to like what you did versus like what you said, like the book did, it's just really the order. So yeah.
Yeah, just the order.
Yeah.
But I assumed this as like okay, that was not perfect, you know. Like the way it should be.
Yeah. I mean, it's fine. It's like yeah, definitely. The interviewer would probably ask, okay, well, what if I asked you to make everything in the in order, and then you would have just copy pasted this to there, hopefully.
Yeah,
but because it's the exact same thing, so it's not a problem at all. I honestly don't care about that issue, so it's fine.
Okay.
I mean, if they told you very explicitly in the in the problem to tell you to do it in order, then yeah, you should have done that. But okay. Other than that, I liked what you did here. I think that yeah, you recognize what the inefficiency was and just kind of went with it. I'm cool with that. Let's see next. Let me just quickly go through this before I look at your replay. There's a logical problem. I was able to go pretty fast covering the corner cases while encoding last count 15 minutes. Okay, I'm not concerned. Order agnostic. I messed up on the division of integer, which turns into a float. Okay, yeah, like small little mistakes like that. I would say definitely just keep those in mind, and because it's usually the small shit that gets people. But right now we're focused on the big one. Just when you look back on it before your interview, look at these small mistakes of recognizing division of integers. But whatever. I did the verification, ascending closer, which made me do a mistake on binary search. Therefore, if a binary search has do modification, do try to make it a more coupled way to make things easier to visualize. Yeah, try to. It's what I call chunking. Is that if I want to separate things into A, B, C, condition A, condition B, condition C, and then do everything inside those conditions. Especially if the steps are independent. Okay, binary search is going to try running last possible. Always make sure they have the end element going to represent the ceiling. Yeah, so this one I would say the mistake you should have made is like when do you I'm noticing that you don't know when to terminate for the binary search tree.
Yeah, basically was that. Yeah, that was like the small detail I was trying to tell you. Yeah.
So did you were you able to solve the problem or like perfectly or not?
I was able just I wouldn't say that was perfect, but was just like the return. I messed it up on the return, but the whole logic was the same.
Okay, why did you mess?
Only
okay.
one.
Oh, wait, let's put a pause there. You said you messed up on the return value.
Yeah, there was like as you mentioned, like I was like not knowing if I should return like the start or the end. You know, yeah.
Okay.
I figure out if I do it slow while testing my approach, it's greater for me to visualize which one I should to return. I was going kind of fast, you know, and I was like passing over this detail, which is like the answer, you know.
Yeah, that's the answer. Yeah. So I always say, did you run through your code? And I'm noticing like the 13, 14 minute. I know you're like trying to say, oh, I need to go faster. No, I want you to be correct before you're fast. And so this is like kind of a red flag to me.
Yeah. Oh yeah, but I'd say that those exercises were easier to me. Those that I'm gonna do again because of those little details, I was not satisfied.
Yeah, I don't want, and I would say it's a big detail actually, because if you're trying to solve a problem, right, you want to make sure that you return back the right value. So make sure that this is actually like really good. So make sure that this is correct.
Okay. I'm gonna redo like few of them for sure.
Anything that you feel like you rushed it or that was unforced error, that you should redo, especially if it's a core to the problem. I would argue this is a little bit bigger than you think. The only difference is if the grokking, the only reason you should not feel bad is if you come up with a different solution that works, but there was like one or two optimizations that you missed that weren't super obvious. That one is okay. What is not okay is if you just plain do not get the right answer. Like if your answer doesn't produce the right result, that's when you should feel bad. So I would say definitely increase your testing of the code that once you're done with it, or at least your testing of your design a little bit more.
Yeah, I figure out that basically test my idea first. You know, like while creating the design is basically where I should have improved, like in those exercises, because I would not mess it up on the idea, and then therefore not the code. You know, but yeah, those layers of tests would save my life in those exercises.
Yeah, and remember, this is practice. This is not a real thing. So you have the luxury of making mistakes here, but then you also need to fix those mistakes. So for instance, let's say like you test your code, and you realize you hit a bug, right? Then in your practice diary, you should say, "Hey, well, I made this mistake. I had a bug, and I need to fix it. So what can I do beforehand to avoid doing that?" That's what you should be thinking. So. Okay. So
the same thing. Yeah, the same goes back to the
I present the most naive approach to a traverse. I showed that it would.
I'm just putting like just for marking like the naive approach that is to traverse the entire array, and that's basically this.
Learned the mistake I did, improve it as I had to apply the concept to find the maximum and do 2 binary search. Okay. Yeah. Let me see your replay. Hold up. Let me download it.
Okay. There are a few ones that my solution worked. You know, I test, then I like run the Python code. But I saw that grokking solution was better than mine, and I was like trying to let me see what they did that I don't. You know.
Okay. So let me see, which one do you want me to look at? I can look at probably 2.
Just a minute. Let me see if I have a third one. I'd say that the last one. That is not the mock. I guess like the last that I recorded, that was the exercise from Saturday, because I took too long time. You know, too much time.
Okay, which one do you want me to look at? The test
exercise from Saturday.
Exercise from Saturday. Okay, I'll download that.
And I think another good one. Yeah, the number range is recorded. If you want to check like my approach, it took too much time.
That's fine. I'd rather take a look at every single detail that you do anyway.
Yeah.
Because usually, like when it comes to like problems, there's almost always only like 3 or 4 mistakes or 3 or 4 key points that I really need to look at. The rest is just whatever.
Great.
I think one of the things I used to do was like really nitpick everything, but then I realized this was going over a lot of people's heads. So as long as I pick like 3 things for you to work on, that are the macro ideas, then that's good enough. Because there's always more that we can do. But you know, at some point, it just becomes goes through one ear, goes out the other. So I'd rather just focus on the big picture stuff. So.
Great.
All right, so let's see. Exercise from Saturday. Let's take a look at this one.
Yeah, this one was the session one.
Hey, it doesn't look like shit.
Huh?
It doesn't look like low quality shit now. I can actually read.
Oh yeah, great. Yeah.
Okay. All right, so let me see.
Read.
Okay, so it's supposed to block a string. So this is the one I gave you. Okay.
Yeah, this is the one.
All right, hold up.
Just make sure to go through over the steps you.
Yeah, hold on. I'm listening to you what you're saying in the video. So give me a sec.
No, actually, like visited that are in the set, like strings visited are the ones in the set. Okay, so then I'll go to like is it my visit set? Yeah. And then I'll put 2 right here. And I'll keep track of like where it starts. I'll consider that this is the second word in the dictionary, like in the list. So yeah. Start being like, yeah, in the L. It's not in. Then I'll go to the next 4.
I think
So,
I
yeah. So basically, what
stay too much time explaining the naive approach.
That's fine. It's fine. I'd rather you spend a lot of time on a naive approach. It's actually only 5 minutes in. That's fine.
It's better to see like another case.
So okay, as long as you make sure you understand it.
So
Okay.
same thing here. So imagine that I break down this string here and the other up until the 4. Now I found this and I stop. Okay, but the size of it is 1, 2, 3, 4, 5. Great. Starting from the second, I will check if I found a smaller one. So yeah, and then I have to reset my set here.
Okay. Correct. Fine. I'm fine with that.
I'll put this in the map. Comparing. Same. From. Actually, what we can make better.
Yeah, so repeated work by comparing the same string. Okay. Yeah, so basically you just start up like from pointer 1, pointer 2, like 6, 1, then 6, 1, 2, then 6, 1, 2, 3, blah, blah, blah. And then 1, 2, 1, 2, 2, 1, 2, 3, et cetera, et cetera. And you're just basically looking to make sure that for each one you've found all the visited sets and then pick the smallest one. So basically try every single possible combination of strings with 2 pointers. Yeah. So I'm fine with that. The thing is that what I noticed is that you took your time step by step to explain it. That's fine. And you know when you can stop explaining when it becomes immediately obvious how the algorithm runs. It should be immediately obvious to you. Like again, like there's this idea of it will hit you like a brick, and until you get to that point, then you shouldn't. You should keep going, or at least describe more details. Because, sometimes the interviewer is not going to get it, right? So it's really important that you're able to do this step by step until the interviewer says, okay, I understand what you're doing.
Okay, even for the naive solution, right?
Even the naive
make
solution.
sure that.
Yeah.
Okay.
Because the thing is that if you say something and the interviewer just, because English and language in general is like an approximation of ideas. So even though we might be talking about I might be saying something you might interpret as a completely different thing, even though, and there might be some misunderstanding. So doing an example and being able to do this step for the interviewer is really important if it happens, if you need to do it.
Great.
So this is just an exercise simply to get you to do it and be able to do it if the interviewer says, I have no idea what you're talking about.
Okay.
So I'm fine with this, but it should be very obvious to you what it is. So yeah, so you're doing repeated work, same strings over and over again. It's comparing the starting points, will not have additional search from minimum chunk. Order n squared. Okay, so let's say here, why is it n squared? Let me ask you this.
Because of the repeated work I was doing, like repeating over and over again.
No, I want a more straightforward answer. I want one that's not as super vague. I want one that is detailed.
Because for each element, I'm comparing through like the other elements of the string. Is this better?
Not really. Let me show you how I would have done it, and maybe that will give you some sense of what I want. Where is the sheet? Okay, yeah. So I'm going to go to the prep doc, right? So let's say I did your approach of like for every word in the string, check every word. String at, let's say at I, right? Check every word, check every string constructed between I and I plus 1, 2, and then, whatever, X, right? If the string contains all the words in the desired set, check the length and record the minimum, right? So this is the way I would do it, right? So check every word at the string at I, right? So then this will be an order n operation. Check every string constructed between I plus 1, I 2. So each time you're going to be doing basically n number of operations. That's why it's n squared. Does it make sense? So, or
it's more clear.
Yeah. But in this case, in order for me to double check this, because this is my intuition, but then I would say, okay, so then I would do n, and then for each one I just do at this operation I'm going to be doing, for each string I'll be doing n, I'll do n operations plus n minus 1 plus n minus 2, and then that's for the first set, and then I do n minus 1 plus n minus 2 plus n minus 3, So this is the way I would also explain it alternatively, just to make sure that I was doing the right thing. And
Like
then
the
dot, dot, dot.
recurrence relation.
Yeah, it's the recurrence relationship, and then I would try to justify it based off this, just to make sure that what I'm saying here is correct. So
Oh,
you see what
okay.
I'm doing here?
Yeah.
Yeah. So or something like this. Either way, like just I would try to graph this and then just say what order each of these operations are. So that's why it's n squared.
Okay, I was like, it was pretty vague what I was
Yes.
saying, right?
Correct.
So, yeah.
So you notice the difference between what I did and what you did.
Totally, yeah.
Yep.
Yeah.
So I want you to be a little bit more cognizant of that when you describe it. So we haven't worked too much on it. Don't sweat too much, but just be aware.
Set.
Okay.
Okay. So right, we can make better out the fact of comparing over and over again. Yes, correct. Okay. So you did that. You walked through it.
Have
Okay. So instead.
Yeah, I think. Yeah.
Okay. I'm just trying to make sure that that I understand what you're doing
and,
here.
Actually, this is the size, right? 1, 2, 2.
Okay, so you're only looking at the elements that are in that given set. Okay, that's fine. And so you don't need to, after this, you don't need to necessarily do the step-by-step over and over again. I think it's pretty obvious that, okay, instead of like looking at every single word in the string, you're just looking at words that are in the given set. So you don't need to actually walk through it. Again, this is like one of those situations where I think at this point you understood what you're doing. I think the interviewer understood, like, hey, instead of visiting 612, you just visit only 224.
Okay. I should have said, say, right? Okay.
Yeah. Again, like this is like an exercise to help the interviewer understand. But if this is plainly obvious to you, like it needs to like basically slap you across the face, and I think it did. So you don't need to do this step by step.
It was. Yeah.
Yeah.
Yeah, it was.
Yeah, if it feels like it's like if it feels like you are chewing a very dry piece of chicken, then you can probably skip it. Like you're just like, oh my god, why am I doing this? I already know the answer. I already know what I'm doing here, and I already know how this is gonna go. You know. That's and if you know very distinctly that it's gonna be like that, then you don't need to do this.
Because
Okay, there will be a lot of points in this.
Yep,
Like,
that's fine.
that is-
I'd rather you do this than not do it, to be honest.
from
Okay, so then your inefficiency here is that okay. What do you try to find the smaller range will still contain all elements within the set. When both sets are in the remove start element.
check the
I was trying to like
in its
most
Now
optimal
we have
parts
Okay, let me see
with
how
what I have.
more vulnerable elements are within the set. Yeah. So instead, you decide to say, oh yeah, just take the indices of the ranges. That's fine. It's fine. Summary of the algorithm. First, break all the words into a string by space, and put tuple. So you okay. This break all the words in the string by space, and put it in a tuple of string name, string. I would say string position, but fine. Mark all the tuples that contain valid elements in the given string. Okay.
Yeah, I
sure.
think there's a lot of repeated work.
That's
I
fine.
could like improve more, but
I'd rather you be
most-
this detailed and be this careful, but then you'll speed it up later on. Find the smallest range which contains all elements of the given set. When both sets are in the same size, remove elements. Blah blah blah. To return a chunk that is small. I would say you can define this a little bit. How to describe this? Let me see how you exactly do this. Fine. Set 245. Yep. Okay. I like this. I like this. The moment like this is just too wordy for me for my algorithm, for my taste. But I like you do when you did this. So you basically just take every single possible combination of the indices themselves.
yeah.
But that's still
definitely.
relatively n squared,
That was-
I believe.
No,
Is it?
no, because it's like I'm shrinking and expanding. You know, like the window, just a sliding window kind of thing.
Okay. Okay, that's fine.
And then it's like the algorithm.
All right. Yeah. I think that you basically have the right idea.
like
I'm not gonna look at too much whether you have the wrong answer. But yeah. Basically, from what I noticed, the biggest look at where the biggest chunk goes into actually. It's like you build it up, and then I would say the last 20 minutes is just you coding it.
No, like the last 15 minutes.
Last 15 minutes.
Because
yeah.
I was coding and explaining again, going back and forth,
That's fine. So basically 40 minutes to just like come up with the idea. I feel like you can shave off 15 to 20 minutes of that, by basically not chewing the dry chicken, per se.
Oh, the dry chicken,
Yeah, let's call it eating dry chicken. You can skip that, especially again, like I said, like a lot of these things should be plainly obvious. I think your algorithm at the end when you described it was a little bit too wordy. I would have you rather done this first. And the way I would have done this is I would have kept like a hash map of ordered lists of like 2, 4, 5 or n number of sets, and then do a bunch of pointers where I just look at the minimum and the maximum between the ranges, and then within that I evict, and then move the pointer up. So either way, I think you have the right idea anyway. And I would have asked myself if I could have gotten faster than this. Other than that, I think you have the right idea. So the next thing I would say for you to do is to be aware of the dry chicken. If you are chewing dry chicken, you can probably skip. And then the second one is leave a more concise note of what you're doing. So in your case, I would have said create a list of tuples that represent all the places that I can find the desired words. So then that would just be name and word position. I summarized basically your first 2 steps in just this very, very simple phrase.
Yeah, you were more efficient with words than I was.
Yeah, and then be more efficient with your words. I think this is also something that you should try to look at when you look back at your mistakes. Like, if you can be more precise with your words, more efficient with your words, and still convey the right idea, and still have the ability to dive into the details like this, that's the golden goose. We want this. So, I think this is probably something that you might want to look at. Yeah, and then the third one, I would say it's a little bit tricky, because it's like when you did this third step here, when you said, hey, find the smallest range which contains all the elements of size, when both sets are the same size, I think I'd be a little bit more precise with this, and I'm going to leave that as an exercise to you. How can you be more precise and explain like I'm 5? Like, like imagine a 5-year-old's reading this.
Okay. Yeah, again, 5 years old.
Yeah.
Okay. I'll So, just to see if I understand clearly. For the parts that are like the dry chicken one, be more efficient with my words, to go faster. With the parts that I feel that are more complicated, can I still play with a chicken to a 5 years old understand kind of that?
Yeah. If it's complicated and you feel like, oh, someone's not going to understand it, feel free to keep going at it until you fully understand the idea. And then once you fully understand the idea, you should be able to make it easy and simple to understand like I did.
Great. It's expanding and then contracting.
Correct.
Yeah. Okay.
Man, by trying the idea out, once you understand it, then simplify it. Yep. That's the best way I can describe how to do this. But yeah, right now, the fact that you can do this and still get to a correct answer is fine. And I want this, but now we're going to work on simplifying the idea, and you'll get faster with this as you get more practice. Also, I would say be more careful about your solutions. Like I said, with the ones that use, was it the modified binary search? You said that, it's just a small mistake, but it's a pretty big mistake if you can't get the answer.
Sure, for sure.
Or if you can't get the right answer. There's the difference between the right answer and the most efficient answer, but I'd rather you get an answer that is correct and can give you the right answers all the time. So I want you to be able to do this. Be very, be very aware of it.
Okay.
I think that's going to take care of that. Let me look at the other one you sent me. The number one.
If you want to see the mock interview, I think exercise that I have a little bit of a hard time in the beginning.
Okay.
But with the right questions, as you mentioned, right? For me to let me figure out the inefficiency and do all that stuff. I was able to derive a good solution. If you can, if it's okay for you to skip the first 5 minutes, because my friend was having a hard time to explain to me, and I was getting the idea.
That's fine.
Is this the number range?
The number range is the mock interview?
Oh yeah. No, the mock interview is on the title, mock interview.
Oh, okay. Let me download that.
Sorry, I said to you to see that one, but I think I'll get more from the mock interview then, just to see if like the backs are.
Okay, so you want me to look at the mock interview, but I'm seeing only exercise from Saturday, number range, next letter, search elements, and tested 3 binary search tree. I don't see mock interview in the drive.
Whatever.
Yeah, I don't see it in the drive.
No, it's test if a 3 binary search tree nodes are totally ordered. Mock in parentheses. Mock.
Oh, I see now. Okay, the tile got cut off for me.
Yeah.
Okay, cool. I will download that and let's take a look at it.
Yeah. Just to mention one thing here, like before sleeping, I put like a Pavlo video just to see where he was like messing up the most, to see if I having the same hard times. Basically, it's the same thing for everyone. Like in the beginning is like the worst part in the first weeks, then gets kind of more easier, right?
Yeah, I don't think it fully clicked with him until like the 5th or 6th week even. So don't worry about it.
No, I was just saying, okay, maybe a day I can be in the same position.
Yeah, but it's like you're only on week 3. Don't worry, you still have like another 3 weeks. And besides, he has 8 years of experience. Don't try to compare yourself to that when you're a new grad. You take your time, man. There's no reason to rush. Like people who are engineers and actually think about these things, a lot of these come a little bit faster and much more naturally. So if you're trying to compare yourself to someone with that many years of experience, you're probably gonna fail like 99 times out of 100. Yeah, it's like if you were a giga genius, you probably like would have figured a lot of this out by now. But I'm not even that smart, so it's like just take your time with it. That's all I'm saying.
Okay. Yeah. Okay. Step back.
Okay, so you're going through this.
And it is ordered, right? So 19 is less than 23 because 23 comes to the right of 19.
Yeah, if you can skip this first part. He was trying to explain me, but he also was not understanding, but I figure out faster than him.
Good.
Yeah. Let's see.
Okay, yeah, I'm trying to understand the problem as well. So you see test if 3 binary search tree nodes are ordered. So node 1, node 2, and middle. So actually, have this. Why don't you explain to me the problem?
Okay, basically, node 1, node 2, right in the middle, have to find like a path in a tree, like where they are in the same order. For example, like 19, I think it's 27, right? 23. Like 23 must be in the middle of 19 and 27, And yeah. There's like 2 ways. It can be after, like the 20, like a little blur to me to see.
Got it.
But yeah, it must have been the order on like the traversal, So imagine that I'm doing a depth first search in a tree, and the path
stop. If you're having to explain it like that, then you probably are going to you're starting to explain the solution. So let's rewind. So you're saying that given 3 nodes, you want to see if node 1 is less than middle, which is less than node 2. Is that correct?
Yes, that is correct.
Okay.
But no, but here's one thing. If the node 2 is smaller than the node 1, it's a valid case as well.
Got it. So you want to see if node 1 is greater than middle, then node 2, and then node 2, or node 2, middle, node 1. Okay, now that we understand that. Perfect. Okay.
That was one case that I missed, and
But you notice like what I just did, right? I just simply asked you, what is our input? What is our output? What exactly are we trying to solve here? And all I did was ask about the big picture idea. And then you actually, and when you tried to explain it, you went into the algorithm.
Yeah, I went into the algorithm.
Yeah. So that's the difference. When you're trying to identify like what exactly the interviewer is asking, you should always think about like the big picture, irrelevant of code. I don't even know what the implementation is going to be. All I care about is input, output, and what these nodes represent.
Okay.
That's it. And it's like you should be able to do that very, very quickly. Anyway, so let me see what you do here.
I was just running an example of false just because.
Okay.
He was explaining again.
So you spent the first 15 minutes explaining.
In the third element,
Yeah, because he was understanding as well. Yeah.
That's
I
fine.
said, man, if you can ask me this next question that I had to practice, would be good.
Yeah.
And then
So,
he was
I
like
think basically
understanding as well.
the reason why I'm using this array, is
Then
just
I-
to check
Okay.
You can listen.
Let me see. Let me listen to
if
what
the
you're
node
doing
1
here.
is going to be in the position 0, right? The position 0.
Okay.
And like the middle in the position 1, and
Okay.
the node 2 in the position. Actually, the node 2 value. I mean,
Okay.
in the position.
But-
Yeah, as I mentioned, I'm going to start from every node, right? So for node 1 and node 2,
Mhm.
I will start like to do searches on this tree.
Okay.
And then let me draw this example here to see how that goes.
You say you do searches. That's a little bit weak. I like what kind of search? In order, order, post order. I would have specified the high level algorithm first. Before I went into the example, just to give the interviewer a taste of like what's coming.
Okay.
I'll
Take a
go into
note.
do like I can actually.
It's like if like you're saying, hey, I want to do some search. It's like, what does that mean? You know, okay, are you doing pre-order, post-order search? Are you just doing? Are you searching through the binary search tree? I want you to give me like a taste of what's coming.
Actually do kind of a
Okay,
binary
okay.
search to try to find our
I'll be aware of this.
validation. Yeah, was the middle, and the position 2 is supposed to be the 13, and it was.
Okay, let's see what you do here.
And then I'll go. 11, right? 17. And
Yeah, I was just basically traversing
and
and
the 13.
like
Then I'll end the
comparing with the
Once it's
array.
reached the
I
size of
was
3, like
loading
it's
along
going
the
to-
way.
Okay, so I see. So you're saying you're gonna traverse the tree in some way, and then you're gonna collect all the numbers. And
Not all the numbers, just the valid ones.
the numbers that we're looking for, whether that's N1, N2, or mid.
Yeah.
And then as you encounter them, you put them in the array.
We are all going to verify
Yes.
this condition.
Got it.
Yes. And then compare the order. If like the middle is in the middle,
Mhm.
is it in between, like the ones that it should be. Yeah.
Yeah, you should be saying that beforehand. The only reason you do this explanation before is if you're saying, "Hey, I don't know what the answer is going to be," then I'm gonna just try some stuff out. That's fine. But if it seems like you already had some idea, I want you to say it
Yes.
beforehand. That way, I understand like what you're trying to do here. There's a very big difference actually, and I know it's like seems a little pedantic, but the reason why is because one's an exploration. It's like you are leading the interviewer, you're leading the discussion. You want to be the one setting the expectations. Does that make
Okay.
sense?
So the thing of like kind of like write a summary like in the beginning before like testing the idea, right?
It's not quite that. It's like if you know where you're going, you should be able to tell the interviewer, "Hey, this is my idea on a surface level. This is where I'm heading." You know, and being very explicit with that. The other times it's like you can say, "Oh, I don't know what the answer is. Let me try some ideas out." That will help the interviewer
okay.
follow you.
There's two difference. Yeah.
There's two differences. And the reason why is like it's like when you said like, "Oh, I'm going to do some searches." Like I don't know what that means. I don't know that it's like just it doesn't mean anything, and I'm trying to figure it out, and I'm going to spend all my time thinking about what does he mean by search. And I get that you saved yourself by walking through it, but I'd rather you be a lot clearer in the beginning and just make it like very simple for me to understand.
Okay.
That's it.
I'll take a note here.
Yeah.
as well.
It's like setting those expectations.
Like,
It's a small thing, but it will help you as well because it will give you a compass where to follow.
validate.
So actually, I have no problem with this. Other than that, your initial solution's fine.
and in this case, the node 1 is going to be 19.
Yeah.
The position 0 is going to be 19.
Okay, and then you just check the order of the array. Fine.
Thanks for that.
And I just missed the case, like because it can be in different orders, right? So
Not equal to any of the values.
20 is it at 19? I guess it's 19 and 13, right? On the
Uh huh.
pages.
Yep.
So yeah, the other case should be valid as well. So if it was 13 or 17 or like inverted, and I didn't check this, and he like called my attention. And if it was the other way around, so what you would do? And then I figure out, and then I tested, and then implemented again.
Okay.
I went back to like.
Question: Why is this one on line 23, 24, and 25 false?
Which one?
I'm looking at the So you see here, like it says n equals 1 equals 19, n equals 2 equals 49, and mid equals 23. Why is that false?
Just a moment. Oh, because 49 is not in the same branch as like the 23. How can I put this in more clear words?
Yep,
For
explain
example,
like
if I
I'm
go from if it was like 29, 43, and then 49, and 43 in the middle, it will be okay.
No, give me the
But-
high level idea. You're not allowed to say.
Okay,
yeah.
okay.
Give me the high level idea.
High level idea is while doing reversing this tree, the same path of the traversal, the 23 is not gonna be in the middle of the 29 and the 43.
Oh.
So it was good.
Okay, you could have just said, okay, so the answer would have been that 23 is not in the path between 19 and 49.
Yeah, that is. Yeah.
See, like that's the level of clarity that you need to get to.
Okay.
It just needs to be that simple, high-level idea. And notice, like, I understood it.
Not in the path.
Yeah, notice, like, you just said path. Like, oh, okay, you could have just said path, and that's the key to understanding it. So,
Yeah, and I said like 12 words before I say path.
yeah, you could say just the path between mid must exist on the path between N1 and N2. And once you have that, that's fine. Okay. Anyway, so let's see. Okay.
Yeah, so
So,
I was just explaining.
Yep. Okay. So anyway, so your goal the high level idea would have been to create a path between N1 and N2, and then see if mid exists along that. That's literally what you're doing here with the validation array.
Yeah.
But except for the fact that I don't think the solution works because you do an LVR traversal, which means that you can potentially hit what's called in the third example you'll hit 19, and then you do an LVR traversal, you hit 23, and then hit 49. So that's the problem. Your algorithm doesn't actually work.
Oh no! Can you explain me again, please?
So you said that you said, well, at least in my understanding. My understanding is that you're doing a in order traversal. So but that means that it will fail the 19, 49, and 23 case because you'll visit 19, add that to the array, right? Then you'll go you'll go to 43, and then you'll go to 23. 23 is encountered, so that way you'll visit the array, right? And then you'll backtrack and then hit 47 or 49. So, in other words, even though, like you told me, that the path between 19 and 49 is what is required, you'll find 23 outside of that path, and yet your current algorithm return.
But the thing is, I made a copy, so I was not gonna have like the old list, when I'll backtrack. That was the thing I was very aware of.
Okay.
Don't fall in this case. You explain me. Yeah.
Okay. Yeah. So that you would I think if you explain that, that's fine. I would have liked to like you address that, but that's fine. I'm going to assume that you did here.
Yeah, I did like on the implementation, and I explained it to him at some point that I don't know the timestamp. Yeah.
Okay, I think that you should have explained it when you're discussing the idea because this is something that a engineer would have brought up. So
okay,
because it's just like explain how it gets around all these different test cases before you commit your code.
Yeah, I think that part was one, like I just figured out along the way.
Okay.
But it was not that clear to me.
Okay. That's fine. You put the basic idea down, and then you can always go over it. Okay, that's fine. Get all the values, put them in the validation structure, traverse the array DFS from 1 to 2, and the current element value into the order array. Pass a copy. Okay. So the reason why the copy is there is so you can pop out. Okay, that's fine.
Or I could pop out or like pass a copy.
Yeah, I would say I wouldn't say pass a copy. I would have said like pass reference, and then you can always like backtrack by removing the element. That's fine as well.
Okay.
I understand why the copy's there, and this is probably a discussion point to, like for optimization, but it's fine. If I saw you do, but like I'm gonna say like if I saw you do this, I probably would have put you on borderline, because then I would have said, okay, well you made copies of these, how can you make this faster? And then we would have had a discussion of like optimization, and you could said, oh, instead of backtrack, but I would have expected you to do the backtrack instead of copying method right off the bat, to be honest. So.
Okay.
Other than that, yeah, I would say it's like lukewarm average. It's like your approach is correct, but it's just that these little, like you mentioned, the details.
And you even said, like, I guess on the first replay analysis, you said avoid those copies, right? Because it's too much memory. Yeah. I should be aware of this.
Yeah, and you should be like you should already, because if you made that mistake in practice, you should already know what the optimization for that is, which is just add elements to the list and then pop it out. That should have automatically come here. So that's it. And then here should have been in order. Other than that, like I said, the performance is like average. Being able to say ahead of time what exactly you need to do. And I think you took a little bit too long because the code didn't actually take that long. You testing is fine here. I think you being overly explaining the idea as a compensation for not being able to explain the idea like at year 5. That's it. If you dive into the example, but that's because I'm making you do it. But now we want to get to a point where you can explain that idea in a very simple like sentence, like in less than in 10 words or so, without having to do this.
All right.
So,
okay.
That's the next step. You want to be able to explain the idea without like being overly obsessive about the details. So.
Okay, good. Not forgetting about then like being more effective with my words, right?
Correct.
Okay.
So it's fine. Like I make you do the details so that way you can do it if it need be. But I want you to start putting yourself in a position where you can explain like your 5, like what I've been doing, in a very simple sentence that captures all this.
Okay. Okay. Hello. Hello.
Yep.
I think connection just break a little bit. Yep.
Okay, that's fine. I've written down what exactly I want you to focus on. So it's a little bit more about like being able to set yourself up for more efficiency. That's it. And I think with this, you'll get a lot faster.
Okay.
Okay. That's it for feedback from me. Is there anything else you want me to look at?
I think that was it. But yeah, just I informed you about the progress
Uh-huh.
and about the previous week's assignments.
Yep.
I did like the one. I guess I will do again because it was not that clear to me. I'll do again the NR tree like code and decode because the last time I missed few details. You know, and like with this habits that I build.
Uh-huh.
In the meantime, will help me. I'll do then again. I did this from the last coaching session, and I will see if there's like anything else.
Okay.
And yeah, I will move to 2 pointers, do the write up as you said, the sliding window, and the array. But before this, I think I'm gonna redo the other exercises since the idea is more clear. But I should do like with the details kind of thing. And is this okay? Like.
That's fine. Redoing problems is I'm always in favor of that. That way you can make sure that you fully understand what you're actually doing. And then you also have plenty of homework still left to do in EPI and grokking. So I think you have plenty of work on your plate. But definitely try to implement these ideas of being more efficient with your words and trying to capture all the details in a sentence.
Okay, I'll put this in practice.
Yep.
From now.
Anything else that you got going?
Oh, I think that's it.
Okay.
Oh yeah, that's it.
Okay, cool. And then just
Thank
be
you
aware
very
of the
much
dry chicken.
for the feedback.
Yeah.
Mhm.
Okay. Then I'll let you
Okay.
go.
Okay, have a good night, man.
All right, you too, man. Take care. See you on Saturday.
You too.
All right, bye-bye. Okay, that was it. Any questions from the stream about what happened? I mean, he's getting better. At least he's able to get to a point where he can solve any problem. Now we just have to make him a little bit more efficient and make him like communicate better with this explain like I'm 5. I think that'll he'll see like a very big jump from that. But at least he's able to solve problems now, so that's fine. Going once, going twice. All right. I guess that's it then. You know what? I'll see you guys Saturday. We will be streaming at 11 a.m. Pacific Standard Time. That'll be our 4th week working with him. Hopefully he's made some progress. Hopefully he'll implement all these things that I've talked about. So if you guys want coaching yourselves or go through a similar process, you can book me for interview coaching at echantech.com. Link is in the description. You can also join the Discord. I'm very active on there. And if you want career advice, help, or want to chit chat about random stuff, I'll be on there. And a few other high level engineers will be there as well. With that, see you on Saturday and have a good night.